All right, we just finished up with the model that we came up with, and now the next step is we're on our way, we're in between now with the final transformation. We're still kind of formulating it into something we've seen before. The name has changed. It's called the matrix of transition, but really what this is, it's your coefficient matrix. And if you've done everything carefully to begin with, you should not have an issue writing down the matrix of transition. So I don't have my zeros here. I put them back up here. So I have all these, the coefficients lined up. And now the matrix of transition are exactly those coefficients. And just again to cross-check, I'm always frightened that I've made a mistake. I just total up the columns. The total of the columns should all be 1. All right, so that's it for the matrix of transition. You can now answer number 4 on the feedback. So you can pause this video and go to the number 4 on the feedback and answer it. So going next, where are we now? We've taken a real world problem, we transformed it into a mathematical model, and now I want to go to the mathematical solution. Some of that, we've just been doing that to death right now. We've actually done this in Mathematica and put it in and actually looked at the solutions with eigenvalues. I'm not going to do that for you right now, but I do want to I'm curious to see what the plots look like. So let's go there next. All right, so I just put this model into Excel just to see what this looks like. And here's the graph, so you can see it. And so I, again, cross-checked myself here. So let's just look at that, what that is. Okay, so this here is my n. So the hour stands for n. At hour 0, I am going to assume that the baby is pooping, in a state of pooping, and the sum of everything I have here should be 1. It cannot be sleeping and poop. I guess it can be sleeping and pooping. Hey, that's another assumption, right? I'm assuming that they can only be in one state at one time, which anybody who has a baby knows that that's not true. So this is a simplifying assumption. But right now, the way I've modeled it, they can only be in a state of pooping and not something else. So that's my first, everything else has to be 0, and the 1 is in the state of pooping. That's where he is. So in the next step, if you go back and remember in my model, let me screenshot the model. Let's do that together, live. So let's take a screenshot of this. And paste it into here. So you can see the model underneath. Right here. So where does this come from? Well, to get to the next step, I have to take B2, where's my previous SN, and multiply that by 0.58. So I take 0.58 and multiply it times B2. And then I have a 0.3 times pooping. 0.3 times pooping, that's C2. So that's how I get to the next step of sleeping. Let's see, I don't want it to do that. And then each one of these has the model in it. So here you see 0.1 times C2 comes from 0.1 times pooping. C2, the previous state, is in C2. So to get to C3, I need to take 0.10 times C2. And then if you look again into the formula bar, 0.2 times D2, that comes from 0.2 times crying. Crying is in cell D2, so I take 0.2 times D2. So I'm just taking off those coefficients and multiplying. And when it comes to making mistakes in programming, I'm terrible. So I just want to make sure I'm doing things right. So I just have a little sum here where I add up all these probabilities, and I should get 1 if I've done it correctly. So you can see my just cross-check, making sure I have 1 here. And then once I have that, I can just highlight this whole row and then drag it down as far as I want. I just decided to do 24 iterations, and you can see something. You can see that the eigenvalues must be all less than 1 because in magnitude, because it's all converging. In fact, it's positive because it's not oscillating, but I can see that everything's converging. So it looks like the equilibrium is stable, and I can even see the equilibrium in here. Right here is the equilibrium. All right, so I can see all that. I can see that I have all these conditions right. Eating looks like pooping, and sleeping somewhere down here. So you can see where it leveled off at. Now, what if the baby started in a position of sleeping? Well, let's put a 1 here, 0 here, 0 here, and 0 here. Then it changes the graphs. That's interesting, right? The initial condition matters, where it seems to go up and down. Let's see if what it started out with crying. So let's put a 0, 0, 1, 0. See what happens there. So it looks like there's differences initially, but it's leveling off all at the same place. Interesting. So anyways, this is the model. This is how I simulated the model in Excel. You can simulate it in Mathematica. You can solve the whole thing in Mathematica. So all of these things we know how to do, but I just wanted to see what the product of my work was. All right, with that, we will sign off.